Okay, so for this problem, your first step is to draw the free body diagram. So you really need to draw the forces acting on A and the forces acting on box B. So on A, we have the force of the push. We have the force between the two boxes, which I originally called B on A and A on B, and then I read that we were supposed to call it force C, so sorry about that. Then there's a normal force acting on A and the weight of A. On block B, there's the force between the two. There's the normal force pushing up and the weight pushing down. After you have your free body diagram, you need to do the sum of the forces on block A and the sum of the forces on block B. So the sum of the forces is always in the x and the y direction. The sum of the force in the x equals max. So we have the force of the push to the right and the force sub c to the left equals the mass of just A times the acceleration. Three unknowns in that equation, so we leave it alone. In the y direction, we have the normal force minus w sub a equals 0, so the normal force would equal mg, or 14.7 times 9.8. Okay, so then in the on block B, similar steps, the sum of the forces equals ma, so force sub c equals 7.0 times a, and the sum of the force in the y equals, okay, sorry about that, so the sum of the force in the y equals mass times acceleration in the y. Pretty similar steps. I don't know that this normal force even helps us, but we can figure out that the normal force acting on B is 68.6 newtons. But what's helpful is that now we know F sub c equals 7 times A, 7 being the mass of block B. So now we substitute into our original equation. The force of the push was given as 7.5 minus, instead of F sub c we can plug in 7A equals 14.7A. Combine like terms, divide both sides by 21.7, and you end up with 0.346 meters per second squared, which is the acceleration of the system. Take that and plug in to F sub c equals 7 times A, and we get 2.42 newtons. Now part C asks what if we push from the other side, and I feel like you could figure that one out by really just reversing your picture and following these steps again. Hope that helps.